Hello, today we are going to learn how to find descriptive statistics in Excel. So again, I have my bowling scores, and the first thing that you're going to want to do is type whatever data you have. So I just have the title bowling scores and then listed down here. Also, a cool trick in Excel, and this makes things useful for finding some of the statistics, is if you highlight them, make sure you don't drag the corner, by the way, or else you'll copy the first cell all the way down. We're just highlighting all the cells. And mine are already in numerical order. But if you highlight all of them and then right-click and click on Sort, you can go from smallest to largest. And that orders all of the data from smallest to largest. It makes the data easier to look at, and it helps you find some of the descriptive statistics. But let's start finding the statistics. So here's some basic descriptive statistics that you can find. Some of them are just characteristics of the data, not really a descriptive statistic, but I thought it would be worth just discussing it anyway. So let's start with the mean. The mean is also known as the arithmetic average. And whenever you call a function in Excel, what you have to make sure you do is always put an equal sign first. So here, the average or the mean of all of my scores is 196.6. And let's do that, and I'll show you how to do that. Okay, so right now that cell is blank. We have to press an equal sign first. That tells Excel that you are calling a function, and you're going to type the word an average. And you see there's a few averages that pop up. We just want a normal average. So we just want the first one. And then we're going to put a parenthesis, and then we have to highlight the cells that we need to take the average of. So in that case, it's the bowling scores or whatever data that you have. Okay. And then we're going to close that data with another parenthesis, and that's how I got the 196.6. Okay. The next function is the median. Okay, so that's the exact same thing, except you call the function median. So I'll delete this just so I can, again, show you what we need to do in case you didn't get it last time. We're going to press the equal sign. That tells Excel again you're calling a function. We're going to type in the word median because now we're trying to find the median. Again, we highlight our data, close the parenthesis, press enter. And let's scroll up a little bit, and that's the median's 190. So that's the middle number in the data set. The mode, I don't know of a function that actually tells you of a mode in Excel, but it's not usually hard to find the mode. So I just did this manually, and I looked at the data I looked at the numbers, and it turned out that this data set's actually bimodal. 148 and 182 occur twice. Your data sets that you're going to be having only have 30 data points, so finding the mode isn't going to be too bad. If every single data point is unique, or if there are no repeats, then there is no mode. In this case, this is bimodal. Okay. The next one is the IQR. Remember, the IQR is the interquartile range, which is the third quartile minus the first quartile, or the difference between the third and the first quartile. Before we find the IQR, actually, let's find the quartile. So we're going to skip that one for now. The distribution, that's just a characteristic. It's skewed right. And I got actually this from the histogram. So if we go back to the histogram, which we did in a different video, we can look at the distribution of the data. And the distribution of the data is skewed right. It peaks more on the left side, and then we're stretching out the data. Or the data has smaller bars on the right. It has more extreme values on the right side. Okay. The range, remember the range is the maximum minus the minimum. So all I did in this case, this isn't a function in Excel, we can do this by ourselves. And this is one of the useful things about arranging the data from smallest to largest. So we're just going to delete what we have here. Okay. We're going to do equals. And then it's the largest minus the smallest. So the largest minus the smallest, that's the largest, which is all the way at the bottom because we ordered it that way, minus the smallest. And that gives us the range. The next two we're going to talk about is the variance and the standard deviation. The variance and standard deviation, remember, is a measure of how spread out the data is. So when we do this, okay, let's click on variance again, equal sign. Okay, now we're going to start typing var. Okay, now if we look at the functions that call up, we have var.p, var.s, and then we have a few other things down here. var.p and var.s are the variance functions, though. Remember, the variance of a population is calculated slightly differently than the variance of a sample. You have collected samples for your data. You haven't collected an entire population. So we are going to do var.s because the denominator of that formula has the n-1, which is the main difference. So var.s, highlight, close parenthesis, and that gives you the variance. Remember, the standard deviation, which is the next one down, is the square root of the variance. So if you want, you could actually just take the square root of this number and you'll get the standard deviation if you just want to do that on your own. But Excel, again, has a function for us. So I'll show you the function anyway. We're going to click on the blank cell, equal sign, stdev. Again, we're going to do .s because it's the standard deviation of a sample, not of a population. And we're going to highlight those, close parenthesis, enter. And if you square this number, you should get that number because the variance and the standard deviation have that relationship. So you can double check to make sure your work is correct by doing that. Outliers. Remember to use the outlier rule that we discussed in class, which is the interquartile range times 1.5, and then you add that to the third quartile and subtract it from the first quartile. If it's outside, if there's any data that's outside that range, then you know you have an outlier. I'll show you why there's no outliers in this data set in a second after we calculate the quartiles. Okay, let's actually go to the quartiles now. The quartile function is quartile.exe. Okay, we're going to do the first quartile, so that's equals quartile.exe. And notice there's a difference between, there's .exe, let's actually go back. There's .exe and .inc. .exe is what we're used to in class. So we're going to go with the .exe, and highlight this. Now, because it's a quartile, there's 3 quartiles. So you have to tell the Excel program what quartile you're finding. We're finding the first. So we have to put the comma there, 1, and parenthesis, and that gives us the first quartile. You do the same thing with the other quartiles. So the second quartile is the same thing except we put comma 2, and the third quartile is the same thing except we put comma 3. Okay? And that finds the quartile for us. Let's go back to the IQR. The IQR is the third quartile minus the first quartile. So all I did is, if you look up here in the cells, D13 minus D11. Well, D13, it's blue and it's highlighted blue down here, is this number, the third quartile. And D11 is this number, the first quartile. So instead of typing those numbers in and doing it manually, you may want to do it manually, it's up to you, but I just had Excel do it for me and just did the equals and subtracted those cells. Okay? Okay. Remember that the outlier, to find an outlier, we have to look at the third quartile and we're going to subtract the first quartile. Okay? And we get that number. That's the interquartile range, and we're going to multiply it by 1.5. Okay? So that's the first step. So I have a calculator here. So that's 226.5, and we're going to subtract 171.5 because that's the first quartile, and we're going to multiply that times 1.5. Now that gives us 82.5. So I'll write that down. That equals 82.5. Okay. Now we have to add this to the third quartile, and we have to subtract this number from the first quartile. Well, if we subtract this number, let's start with subtracting first. If we subtract this number, 171 minus 171.5 minus 82.5, that gives us 89. Okay. And 89 is smaller than the lowest number in our data set. So we do not have an outlier on the lower end. If we go to the largest, if we go to the third quartile, which is 226.5, and we add 82.5, that gives us 309. And this is an impossible bowling score, because the most you can get in bowling is 300. And the largest bowling score we have, sure enough, is 264. So we do not have an outlier on the upper end either. If perhaps we had a bowling score that was 80, 70, anything below 89, we could call that an outlier. So that's why I have no outliers. Okay, and that's all the descriptive statistics that I really care about for you to have. And I'll see you in the next video.